In this next lesson, we're going to build a window based on an application problem. So here's our application. On wet level pavement, highway engineers sometimes estimate stopping distance d in feet for a car traveling x miles per hour by the model d of x equals to 1/9 x squared plus 11/3 x. We're going to use this model to approximate the speed of a car that takes 180 feet to stop. We're going to solve this graphically, sketch the graph, state our window used, and then write the solution as a complete sentence. So the first thing we need to ask ourselves is, what equation are we trying to solve? So that's 1/9 x squared plus 11/3 x is equal to 180. So the way that we're going to solve this is using the intersection method. So y1 is going to equal the left-hand side of our equation, and y2 is going to equal the right-hand side of our equation. Now the hardest part of this entire problem is figuring out a window. So we need to put ourselves into this problem. We're talking about a car. So my x values here, remember, is miles per hour, so it's the speed of a car. If we think about the cars that we're driving right now, our speed can be from anywhere from 0, we could be completely stopped, to somewhere around the 100s, maybe 120, 140, 150. Here with a window, remember, we can use a little bit of wiggle room. It doesn't need to be exactly a certain number. We just want to make sure that we're going to see an intersection. So here I used 120 as my maximum x value. Since I'm going from 0 to 120, I'm not going to count by ones. I think tens would be a good way to count. You could also count by 20s. Next, we need to do the output. So that's the d of x, my stopping distance. I'm looking for where my car is going to take 180 feet to stop. So again, my minimum y value is 0 feet to stop. A maximum, since I'm looking for where it's going to be 180, I'm going to go a little bit higher and say 200. Again, this is not any exact science. I'm just kind of approximating. So you could have said 185, 200, 500. You could be as generous as you want with that window. Keeping it somewhat near the value of 180 will give us the best opportunity to find that intersection in the window that we want. So let's start entering this into our calculator. So in y equals, y1 is going to be 1/9 x squared plus 11/3 x. So notice how I didn't even touch the calculator until I decided what goes in y1, what goes in y2, and what my window should be. If you always put yourself into the problem, it makes it a lot easier to kind of figure out what would be a logical window to choose. Now that my equations are entered, I'm going to go into my window and type in exactly what we talked about. Okay, now that I have my values entered, I can hit the graph key. So I see there's my polynomial equation, and there's my 180. I see my intersection, I see definite tick marks here. This is exactly what I want to see in my window. Everything is very clear and easy to read. So I'm going to use the intersection method to find what that value of x is. Okay, I have my cursor very close to where the intersection is. First curve, second curve, guess. And I have an intersection at x equals 27. So at this point, I'm going to sketch my graph. Again, it's a sketch. It doesn't have to be perfect. It just should be accurate to what you see on your calculator screen. So there's my sketch. I labeled both of the curves, labeled the intersection, and solved the equation. Okay, our last step is to state the solution as a complete sentence. So what this is saying is that if the car is driving at 27 miles per hour, the stopping distance is 180 feet.